Hi there, grade 10s, and welcome to another Learn Extra lesson. In today's lesson, we are going to be talking about analytical geometry. Analytical geometry is not difficult, and if you practice it hard enough, you can get a lot of marks in that section of your papers. It is also a very important section because we will be meeting analytical geometry again in grade 11 and in grade 12. So what we learn this year will form the foundation for our knowledge on analytical geometry. Right, let's get straight to it, and we'll quickly talk about the Cartesian plane, what are points on the Cartesian plane, and the distance between these points. Now, as long ago as grade 8, you guys would have met the Cartesian plane for the first time. We've got our horizontal x-axis and our vertical y-axis, and we need to be able to plot points on a Cartesian plane. So let's have a look at the point x is 2, y is 3. Remember, your Cartesian coordinates are given to you as an ordered pair, so it's always x first and then y. X is 2, y is 3 will then be over there. Easy as that. Let's do another coordinate quickly. What about x is minus 4 and y is minus 2? I go to minus 4 on the x-axis and minus 2 on the y-axis. And there I have my point. I don't think that this will cause too much of a problem for you guys. We have met the Cartesian plane before, so just a quick revision on plotting points. Okay, so let's have a look at our first question. Typically, this is what we need to be able to do. Let's have a look at the first question. Represent the following figures in the Cartesian plane. So all we have to do is plot these points, and let's do it. The first point is the point D, where x is 1 and y is 2. So x is 1, y is 2 over there, and that is point D. We can put the coordinates in. X is 1, y is 2. The next coordinate is E, where x is 3 and y is 2. So what I'm going to do, I'll leave the coordinates off so that we have enough space. So there's D, and then E, x is 3, y is 2. That is over there. Our next coordinate is F. X is 2 and y is negative 3. So now we're down here. X is 2, y is negative 3. Over there. And we can connect the sides of the triangle. So really, guys, a very easy question. You would have been able to do this in grade 8. Let's have a look at our next question. In our next question, we are again plotting points on the Cartesian plane, but this time we are plotting a quadrilateral. Our quadrilateral is any figure with 4 sides. So let's get right to it. The vertices of this quadrilateral is G. X is 2, y is minus 1. I will put that over there, 2 and minus 1. H, x is 0, y is 2. X is 0, y is 2, is of course on the y-axis. Then I, x is minus 2, y is minus 2 as well. Minus 2 and minus 2. And finally, we have J, x is 1, y is minus 3. So that's over here. Let's just move it down a little bit. And we connect the dots to reveal our 4-sided figure, our quadrilateral. Right. Guys, you're probably shouting from the sidelines, move along, because we all know by now how to orientate ourselves in a Cartesian plane. Now, the next thing that we're going to have a look at is how to calculate the shortest distance between 2 points, and that is, of course, the distance formula. Have a look at the diagram that I have on screen over here. If I have 2 points in a Cartesian plane, like I've got the point A, let's just read off its coordinates quickly. Its coordinates are x is 4 and y is 2. And I've got B over here. X is minus 3. Y is negative 2. It is possible, if the coordinates, the Cartesian coordinates are known, to calculate the shortest distance between those 2 points. And that is, of course, what we call the distance formula. Now, the distance formula is derived by using Pythagoras in our right-angled triangle. Of course, if we have that distance and we have this distance, then the hypotenuse AB, that distance, can be calculated. But let's get straight to the actual formula. The distance formula says the distance between 2 points can be calculated as follows. The x-coordinate of the 1 point minus the x-coordinate of the other point, all of that squared, plus the y-coordinate of the 1 point minus the y-coordinate of the other point, and all of that squared. Now, some formulas have xa and xb in them. Other formulas will have 1 and 2 in them. It really doesn't make a difference. It's all the same thing. It doesn't matter which point you call A and which point you call B, as long as you keep on using the same point first. In other words, I can't take the x value of the one coordinate and subtract the x value of the others and then invert them when I do the y values. That just will not work. So let's have a look at calculating the distance between point A and point B using the distance formula. Right. So what I need to do is take the one x value and subtract the other x value from it. So starting off then with 4, it will be 4 minus negative 3. Put that all in a bracket and square it. Right, so that's the x values. Now, remember to start again with the same point that you used first before. So now I'm going to say plus 2 minus negative 2 and all of that squared again. So this becomes 4 plus 3, which is 7, and 7 squared is 49, and 2 plus 2, which is 4, and 4 squared is 16. I then add the 2 together, and my answer is the square root of 65. Depending on what the question says, you might leave it as root 65 or to 1 or 2 decimal places, depending on the instructions. Right. Now, that was a very simple question. I just had 2 points and I applied the distance formula. When you're faced with questions in an exam, they are often more multidisciplinary. There's more things going on. So let's have a look at question 2. In this question, we're going to be applying our knowledge of the distance formula. Right. So we are told in the diagram below, the vertices of the quadrilateral are F20, G15, H37, and I72. So as we said before, a quadrilateral is a 4-sided figure. The first question they ask is calculate the length, that must be singular, I imagine. Calculate the length of the sides of the side FG. Okay, now I'm not 100% sure what this question meant, whether they wanted us to calculate the length of all of the sides, but we might as well do that because that will just give us the practice that we need. Right, so let's start off with calculating the distance GH. It's a good idea to tell me which side's length you are calculating by using a little subscript. It is not necessary, boys and girls, to rewrite the formula. You are allowed to substitute straight into the formula. So let's start at point H. I'm going to say 3 minus 1, and that is squared. So it's the one x value minus the other x value, and we square it all. Then I'm going to take the y value at h, which is 7. I'm going to subtract the y value at g, which is 5. And I'm squaring all of that. Now you could put this in your calculator, but especially if the numbers are still relatively straightforward, small numbers, it's really not necessary. Right, 3 minus 1 is 2, 2 squared is 4. 7 minus 5 is 2, and 2 squared is 4. So square root of 8, that's not the simplest third form, though I could say 8 is 2 times 2 times 2, so therefore I can take out a 2, and that is 2 root 2. So that would be my answer in simplest third form. Obviously, if I'm asked for the length correct to 1 decimal place, you will then put that in your calculator. Right, so that's the length of side GH. Let's also try and do the length of FI. So I'm going to say the distance of FI equals. Substitute straight away 2 minus 7 squared plus 0 minus 2 squared. Okay, so 2 minus 7 is negative 5. Negative 5 squared is 25. Here I have negative 2 squared, which is 4. And the length of that side is square root of 29. So far, no sides that are equal. I think you guys will agree that once you've done a distance formula question once of this sort anyway, you get the hang of it pretty quickly. But just because practice makes perfect, let's do GF. So the distance GF equals 1 minus 2, everything squared, and 5 minus 0, everything squared. So I get 1 minus 1 squared, which is 1, and 5 squared, which is 25. And the length of that side is square root of 26. Okay, the coordinates of H are 3 and 7. And the coordinates of I are 7 and 2. So HI, distance, (3 minus 7), everything squared, and 7 minus 2, everything squared. Right, so 3 minus 7 is negative 4. Negative 4 squared is 16. And 7 minus 2 is 5. 5 squared is 25. And that gives me the square root of 41. So this quadrilateral, at least I can say, no two sides are equal. So it's not any specific type of quadrilateral, but we've now had 4 times worth of practice of using the distance formula. So really, guys, by now you should almost be able to do it in your sleep. Let's have a look at another distance formula question, but this one is now a little bit more interesting. Okay, remember, there's a couple of things that we can do. We can either give you the 2 coordinates and tell you to calculate the distance. That's pretty straightforward. Or perhaps we can give you the distance and ask you to calculate something in the coordinates. Now, the next question is a question such as that one. Let's have a look. If the length of the line segment joining the points A, which is x is 1 and y is 2, let's indicate that over there. There's A. And B, where x is not given, but the y value is 6. Now they're telling us if the length is 5 units, determine the possible values of x. Now you might say to me, but I don't know where to draw that point. Guys, it doesn't matter. Let's do, for instance, let's put it here where y is equal to 6. X is x and y is 6. And I know that that distance between the two is 5 units. Now the question asks me to determine the possible values of x. Now once again, we are going to use the distance formula, so let's write that down. Distance equals the one x value minus the other, everything squared, plus the one y value minus the other, everything squared. Now, we know now that our distance is 5 units, but guys, do you see that my unknown, the x, is going to be sitting underneath the square root? Now that I don't want. I don't need the complications of an unknown sitting under the square root. So what I'm going to do from the start is I'm going to take my formula and I'm going to square it both sides. So instead of having the distance on the left-hand side, I'm going to put the distance squared. So that will be 25. And now the right-hand side of my formula need no longer contain the square root. So I'm now going to go 1x value, let's start with x, minus the other x value, 1. All of that squared. And then I start again where I started before, so 6 minus 2, everything squared. So guys, what you should see at this point is I'm just going to have a quadratic equation. There's nothing too complicated about this. I just now need to tidy up a little bit here. So multiplying out this bracket, and please guys, don't forget about the middle term. That's x squared minus 2x plus 1. And then I have 6 minus 2, which is 4, and 4 squared, which is 16. Now what I'm going to do straight away is I'm going to bring the 25 over to the other side, so that's minus 25. And of course then a 0 on the left-hand side. Now you can obviously just turn this around with no consequence. So x squared minus 2x minus 8 is equal to 0. Factorize. And I get x minus 4 and x plus 2. Now, boys and girls, that means that I've got 2 possible values for x. X can either be 4 or x can be negative 2. Now, how does that work? Let's go back to our sketch. If x is 4 and y is 6, then I am sitting over here. If x is 4 and y is 6, x4, y 6, then I'm sitting over here. That's more or less how I drew it. But there's another possibility as well. If x is minus 2 and y is 6, then I'm over there. And can you guys see the distance looks more or less the same. So guys, it doesn't matter where you put that coordinate with the unknown x, or it could be an unknown y. Don't worry about it. Just pick a place and don't be surprised if you get two answers. That is absolutely correct. Welcome back, grade 10. Some more analytical geometry. We're into the second part of our lesson, and now we are going to be talking about gradients and straight lines. Right, so gradient, again, something that you guys have met before in grade 9 when you were sketching straight lines. Gradient can also, the word slope can also be used, or inclination, and the gradient refers to how steep upwards or downwards is a line. Now, if I have a look at that line that I've drawn, I can say that this line's gradient is positive. Remember, we use M to indicate gradient, because if you are looking at it from left to right, you will be going uphill. So that is a positive gradient. A negative gradient is going downhill as you look at it from left to right. So, in order to calculate the gradient of a line, what we need, very much the same as with the distance formula, is we need those two Cartesian coordinates. So, let's have a look quickly. Let's start with a point over here where x is 1 and y is 4. And let's then pick another point, let's say over here, where x is 2 and y is -2. Right, so to calculate the gradient, it's the change of y over the change in x. You don't need to write the formula down every time, but there it is if you want it. So let's start with the top point. I'm going to start with the y value, so that's 4, minus -2, and then starting with the same point first again, 1 minus 2. So my gradient is 6 over -1, which is -6. There we have it. The gradient of the line is -6. So very important tip when calculating gradients, as with anything, have a look visually at what you've got and make sure that your answer is consistent with that. So I saw that I had a negative gradient, I also saw that it was steep, and my answer has confirmed it. If you see that a line has a negative gradient and you calculate the gradient and it comes out positive, you must know that you made a sign mistake somewhere and go back and fix it. Okay, now what about the gradients of horizontal lines? I'm going to make a Cartesian plane over here. So let's say I have got a line over here, and this line is parallel to the x-axis. What do I know about this line's gradient? Very, very important. The gradient of a line that is parallel to the x-axis is 0. So if you are told that your line is parallel to the x-axis, your gradient will be 0. Very, very important to remember. And then we have vertical lines. Let's talk about vertical lines quickly. Again, I'm making a Cartesian coordinate. So a vertical line would be a line that's parallel to the y-axis, and the gradient of a vertical line is undefined. It's quite interesting to note why the gradient of a vertical line is undefined. Remember, gradient by definition is the difference in y over the difference in x. Now, the difference in y over the difference in x. Now, if I had to calculate the difference in x on this line, A and B on this line are directly underneath each other, so there is no difference in x. So the delta x will be a 0, and remember, we are not allowed a 0 in the denominator. That makes the expression undefined. Right. Let's have a look quickly at the sort of question that can be asked to see whether we know what to do with our gradients. So we'll have a look at question 4. It says PQRS is a quadrilateral, that's a four-sided figure, with points P0 minus 3, Q negative 4, 5, R2, 7, and S3 minus 2 in a Cartesian plane. Our first question is to calculate the gradient of PS. Now, before you start, have a look at the line PS and think a little bit to yourself, what am I expecting? PS is going uphill from left to right, so it does have a positive gradient, but it's not at all steep. So I don't expect the y's to change very quickly with respect to the x. I'm just going to put the coordinates of P and S in. So P is 0 minus 3. And S is 3 minus 2. And us calculate the gradient of PS. So the gradient of PS. Once again, as with the distance formula, it is not necessary to write down the formula first. You don't get a mark for that. So I'm going to say minus 3 minus 2. Those are my y values. And starting again then from point P, 0 minus 3. So I get minus 3 plus 2, which is minus 1, and minus 3. And of course, the minuses cancel out. And my gradient is 1 over 3. So that means my y values climb 1 for every 3 x values. So that is a positive gradient, and it's not a very steep positive gradient. So again, my answer is consistent with what I visually expected. Right. Moving on from gradients, we are now going to talk about finding the equations of straight lines. Now, this is not that foreign to us because we have dealt with straight lines in grade 9, but let's just give it a quick recap. The first thing that you need if you're going to be calculating the equation of a straight line is its gradient, which is why we revised gradient ever so quickly. So let's write down the formula for gradient, the one y value minus the other over the one x value minus the other. Right, now let's talk about the equation of a straight line. The general equation for a straight line is y is equal to mx plus c. You could also use y is equal to ax plus q. That is also fine. Now, the straight line you would have also seen in your graph section. Remember when you did functions, parabolas? So really, this should just be a little bit of revision. M stands for the gradient, and obviously if you use an A, then the A indicates the gradient, and that is the steepness of the line. C, or Q, indicates the y-intercept, or the shift upwards from the origin. Now, an alternate equation to use when calculating the equation of a straight line, which I think is quite a good method because people tend to make less mistakes, is this one. So y minus y1 is equal to mx minus x1. We're going to talk a little bit just now about how you will apply that formula. Finally, let's talk quickly about points on a line or collinearity. If I have a straight line with a certain equation, I'm going to make something up. Y is equal to x plus 3. it is true that every single point on this line will satisfy this equation. So if I were to take the x coordinate and add 3, it will be the same as the y coordinate. This is also called collinear points. Collinear points are points that lie on the same straight line. And another interesting fact, if I call the one point A, B, C, D, E, F, the gradient between A and B will be the same as the gradient between B and C, will be the same as the gradient between D and E, and so forth, because these points all satisfy the equation for that line. Right, let's have a look at a question that asks us to apply the knowledge of equations of straight lines. Now, we've seen this question before. It talks about PQRS, which is a quadrilateral. It gives us the points. And remember, just now we were asked to calculate the gradient of the line PS, and we said the gradient was 1/3. Now we are asked to calculate the equation of the line segment QR. So let's fill in our points quickly. Q is x is -4, y is 5, and R is x is 2, y is 7. Now, the first thing that I have to do when I calculate the equation of a straight line is I've got to calculate the gradient. Now, very important to have a mental picture of what your answer must be, and it has to be consistent with the sketch, so that if you come up with something that doesn't look plausible, you know to go back. So the line QR has a positive gradient, but it doesn't have a very, a very steep positive gradient. So let's hope that my answer will be consistent with that. So y2 minus y1 over x2 minus x1. Right, so I start off with 5 and subtract from that 7 and -4 -2. 5 minus 7 minus 4 minus 2. Right, so that gives me -2 over -6. And -2 over -6 can be simplified to 1/3. So the gradient of QR is equal to 1/3. Now, I'm not finished yet, but I just want us to look at something quickly. We calculated the gradient of PS just now, and that was also 1/3. So what does that mean if two gradients are the same? What it means is that the two lines are parallel to each other, but we're going to talk about parallel and perpendicular lines a little bit more just now. Right, so now I'm going to write down that second formula, y minus y1 is equal to mx minus x1. And immediately I'm going to substitute in the gradient that I've just calculated, which is 1/3. Now, in the place of in the place of x1 and y1, I am going to substitute a point that lies on my line. Now, it could be either one of these 2 points, Q or R. I'm going to use R because the coordinates are both positive, but it's really up to you. So it's x minus 2 and y minus 7. Now, the only thing still remaining for me to do is to get the equation of this line into standard form. So this becomes, I'm just going to multiply out there, 1/3x minus 2/3, and the 7 goes to the other side. Now, boys and girls, I know at this point you're probably just going to take out your calculators to add those two together, but remember the good old common denominator. Let's do it the old-fashioned way. I'm going to say common denominator of 3. I've got minus 2 times 3 times 3. So that gives me 21. So the equation of my straight line in standard form is y is a third x plus 19 over 3. A third x plus 19 over 3. And 19 over 3, well, 18 over 3 is 6, so 19 over 3 is a little bit more than 6, and that is consistent with my y-intercept on my graph. So far, so good. Right, so very important to remember if you're calculating the equation of a line segment, gradient first. The first thing that you need is the gradient. Once you have the gradient, you can substitute into this formula. Remember, x1 and y1 are simply just any one of the 2 points that lie on your line. There could even be more. And then get the equation into standard form. So that means y on its own on the left-hand side. Right. The next question also now has to do still with this quadrilateral PQRS. And it says, PQRS is a quadrilateral with points P, Q, R, and S. Now, it says, show that x minus 1, 6 is a point on the line. Okay, well, and guys, it's not just good enough. I can see, because my sketch is accurate, that minus 1, 6 is a point on the line. But I have to show it algebraically. Now, there's a couple of ways in which you can do it. You can show that XR, the gradient of XR is the same as the gradient of QX. But alternatively, you can just substitute that point into the equation of our line segment and show that that point satisfies the equation. So our equation was y is 1 over 3 x plus 19 over 3. Now, if you want, you can make your life a little bit easier by multiplying through by 3. It's no longer in standard form then, but that doesn't matter. So 3y is equal to x plus 19. Okay. Now, I'm going to substitute my y value in the place of y, but I'm going to do the left-hand side and the right-hand side separately. So I'm going to say left-hand side equals 3 times y, and the y value is 6. So 3 times 6, which is 18. The right-hand side is x plus 19, and the x coordinate is minus 1. So that's minus 1 plus 19, which also gives me 18. And that is how I know that the equation is satisfied. And then you can write left-hand side equals right-hand side. Therefore, the point x minus 1, 6 lies on the line. Couple of things that are important here. If you are showing that a point lies on a line, you need the equation of the line. You have to treat the left-hand side and the right-hand side separately. Right? So you substitute your y value into the left-hand side, you substitute your x value into the right-hand side. If the point lies on the line, the values that you get will be the same, and you can then say left-hand side equals right-hand side, therefore the point lies on the line. If you don't know whether the point lies on the line and you're investigating, you will do the same thing. In that case, your left-hand side and your right-hand side will not be equal, so you will say left-hand side is not equal to the right-hand side, therefore the point does not lie on the line. But you've got to set this out nicely. You lose a mark if you equate the left-hand side and the right-hand side, and very often another mark is allocated to your conclusion. Left-hand side is right-hand side, so therefore the point lies on the line. So please, guys, make sure that you get that right. Right, we're going to take another short break, and then we're going to go into the last part of our lesson. Please don't go away. Welcome back, guys. We're into the final part of today's lesson on analytical geometry. We hope that you guys have been concentrating and watching, and that things are making sense for you. Right, on with the whole business of straight lines. Now, Couple of things that I now want to talk to you guys about. We've already spoken about gradient. We know that gradient is y2 minus y1 over x2 minus x1. So that we have done. We have spoken about the equation of a straight line. We have dealt with the standard form, which is y is mx plus c, and also with this formula, y minus y1 equal to mx minus x1. What I now want to talk to you guys about is parallel and perpendicular lines. Remember just now in the previous question, I noticed that I had calculated the gradient of two lines and that the gradient of those two lines were equal. In fact, they were both 1 over 3. Now, I said back then that two lines with equal gradients are said to be parallel lines. And parallel lines never intersect each other. Usually we indicate parallel lines with little arrows like that. So the gradient of the one line multiplied by the gradient of the next line, sorry, not multiplied, I'm sorry, I'm thinking ahead already. The gradient of the one line is equal to the gradient of the other line. And guys, they have to be exactly equal, right? It can't be 1 over 2 and minus 1 over 2. If the gradients of the lines are exactly equal, then they are parallel. Now let's look at perpendicular lines. Perpendicular lines intersect each other at a 90-degree angle. So let's see if I can draw a perpendicular. There we go. That looks more or less perpendicular. So they intersect each other at an angle of 90 degrees. Those are what we call perpendicular lines. Now, something very important that you must know about the gradients of perpendicular lines, and that is that the gradient of the one multiplied by the gradient of the other is minus 1. What does that mean? The gradients of the lines have to be negative reciprocals. So, for example, if I know that my one line's gradient is 3 over 2, and I then have another line with a gradient of negative 2 over 3, if I multiply 3 over 2 and negative 2 over 3 with each other, I get an answer of minus 1, and that then means that the lines are perpendicular. What do I mean by negative reciprocal? 3 over 2, if I switch it around, it becomes 2 over 3, and I change the sign. And that is when I know that lines are perpendicular or that they intersect each other at a 90-degree angle. Right, let's have a look at our next question. This question doesn't particularly deal with parallel lines, but there are some interesting facts in it. Right, in the diagram, PQR is an isosceles triangle. Now, maybe a good time to talk about the properties of triangles. Isosceles triangle, two sides equal in length. Scalene triangle, all of the sides different lengths, and equilateral triangle, all the sides the same length. Remember those definitions, right? Now, in this question, what we're going to start doing is putting everything together. The distance formula, as well as the equations of straight lines and gradients, and so on. Right, so we are asked, okay, so in the diagram, PQR is an isosceles triangle with PQ equal to QR. That's fine. The side QR is parallel to the y-axis. That's interesting. So this side QR over here is parallel to the y-axis. Right. Remember, lines that are parallel to the y-axis have a gradient that is undefined. We spoke about this earlier. And lines that are parallel to the x-axis have a gradient of 0. So undefined and 0. Let's have a look at the question. Other interesting things over here is if RQ is parallel to the y-axis, then even though I might not necessarily need it just yet, I can say that the y-coordinate at the x-coordinate at r rather is exactly the same as the x-coordinate at q, because they are perpendicular to the y-axis. They lie directly underneath each other. Anyway, back to the question, calculate the length of PQ. So let's calculate the length of PQ. Whenever we see the word length, we know that we're going to be using the distance formula. So the distance PQ equals, and I'm going to substitute straight into the formula. I'm going to start with the x values, 4 minus 2, everything squared, and 9 minus 1, everything squared. So 4 minus 2 is 6, and 6 squared is 36. And 9 minus 1 is 8, and 8 squared is 64. And if I add 64 and 36 together, I get 100. And of course, the square root of 100 is 10. So PQ is 10 units long. Let's have a look at the next question. Now, and this is just as I suspected, the next question asks us to determine the coordinates of R. Now, this is actually a very sneaky way to ask us the distance formula in reverse. What do I mean? Let's have a look. I've already calculated that PQ is 10 units, so that's all fine. Because of the fact that this triangle is isosceles, RQ is also 10 units. So I'm going to say RQ equals 10 units, and the reason is isosceles triangle. Now remember earlier on, the fact that this line RQ is parallel to the y-axis means that the x-coordinate at R is the same as the x-coordinate at Q. So already I know my x-coordinate. All I need is my y-coordinate. So this is pretty straightforward. I am missing my y-coordinate. I've got the other x-coordinate, and I have the distance. So it's very similar to that question that we did a little bit earlier on. You just had to think a little bit more about the fact that it's 10 units, so you had to know your properties of an isosceles triangle. Also, the fact that the line RQ is parallel to the y-axis, you had to be clever enough to know that means that they have the same x value. Right. From here on forward, it shouldn't be too much of a problem. I have got 4y and 9. And I know that the distance is 10 units. Right, so I'm going to use the distance formula, but squared both sides straight away. So I'm going to omit the square root altogether. You don't really have to write down the distance formula, but in the beginning, maybe that's a good idea. Okay, so on the left-hand side, I've got distance squared, so that's 10 squared, so that's 100. And then I'm going to start with this point. I'm going to say 4 minus 4 squared plus y minus 9 squared. And from this point onwards, all you really need to do is algebra. 4 minus 4 is 0. 0 squared is, of course, still 0. Multiplying out this bracket, please do it properly, boys and girls. Y squared minus 18y. And 9 times 9 is 81. Of course, then I need to bring the 100 over. and it's y squared minus 18y plus 19, minus 19 rather, sorry, minus 19 equal to 0. That's my trinomial. Factorize y minus 19, y plus 1, and it works out beautifully. Y is either equal to 19 or y is equal to negative 1. And remember, boys and girls, I told you earlier on, there will be two possible values, so don't feel that you have to discount one or two of the values. It's fine. It's absolutely perfect. Right. Guys, we're getting to the point now where we're doing lots of questions, where we're seeing what a question in an exam paper is going to look like. Remember, in an exam, what they tend to do is we get one sketch and we get asked to do all sorts of different things. Let's look at question 6. Question 6 says, the coordinates of the vertices of triangle ABC are 2, 3, 5, 7, and minus 2, 6. So that's all very groovy. And the question asks us to show that triangle ABC is a right-angled triangle. Now, just looking at this sketch, it's obviously not drawn 100% to scale. I would imagine that if anything, the right angle or the 90-degree angle would be over here with A. Now, there is more than one way that you can use to prove that it's a 90-degree angle. I'm going to go with the easiest route, but what you can do is calculate the lengths of all three sides and then show that the lengths of the sides satisfy the equation of Pythagoras. X squared plus y squared is equal to r squared. That's a bit of a mission because you've got to do 3 distance calculations and still show that it satisfies the equation. So I don't think we're going to go with that. What I'm going to do is calculate the gradient of AC and then calculate the gradient of AB. Now remember, if two lines are in fact perpendicular, the gradient of the one multiplied by the gradient of the other will be negative 1. And that's what I'm going to be hoping for. So let's start with AC. 6 minus 3 over negative 2 minus 2. So 6 minus 3 gives me 3 over negative 4. Now that is consistent with what I've got in front of me in the sketch. The line does have a negative gradient. It is moving downhill from left to right, so that's fine. So let's do the gradient of AB. 7 minus 3 over 5 minus 2. And that is 4 over 3. And I can see that the gradients of the two lines are negative reciprocals of each other. Now, guys, it isn't just good enough to calculate the two gradients. You can't just do that. You've now got to come to some sort of a conclusion. That's one more mark. So I'm going to write the gradient of AC times the gradient of AB is equal to minus 1. Therefore, angle A is 90 degrees. And that would be absolutely sufficient. Right, let's have a look at what to do next. We've now spoken about gradient of a line, equations of a straight line, parallel and perpendicular lines. There's one more thing that we need to discuss, and that is the midpoint on a line. Now, this, as far as I'm concerned, is possibly the easiest analytical formula of them all. So let's do an example. I'm going to say A is the point x is 4, y is 2, and B is the point x is 8, y is minus 6. And I want to know what are the coordinates of the midpoint of the line segment AB. Now, the formula for midpoint couldn't be easier. To get the x value at the midpoint, we take the one x value, we add it to the other x value, and divide by 2. To get the y value at the midpoint, we take the one y value and the other y value, add them together, and divide by 2. Easy peasy. So let's have a look. My one x value is 4, plus my other x value is 8. That gives me 12 over 2, which is 6. So the x coordinate at the midpoint is 6, then 2 plus negative 6 for my y values over 2. That gives me minus 4 over 2, which is minus 2. So really, guys, any banana can do this. For the midpoint formula, all we have to do, add the two x values together, divide by 2. Add the two y values together, divide by 2, and voila, we have the midpoint. So now we have done everything. We've spoken about the Cartesian plane, we've spoken about gradients, parallel, perpendicular lines, midpoint, we've done the distance formula. Now we can really have a look at a sort of question that encompasses all of these skills. So the first question, question 7, is mostly now on the midpoint. It's actually a really lovely question. It says a minus 2, 3. I'm going to just write the coordinate in. And b, 2, 6 are points in a Cartesian plane. They also tell us that C is the midpoint of AB, and they ask us to find the values of A and B. Guys, very, very easy. We've just done it. Minus 2, the one x value, plus 2, the other x value, divide by 2. Minus 2 plus 2 divided by 2 gives me 0. And what do you know? It does actually look like C is exactly on the y-axis, so that's cool. And then 3 plus 6 over 2, and that gives me 9 over 2, which is 4.5. You could say 9 over 2. And that looks more or less consistent, so straight application of the midpoint formula. Now, just like with the distance formula, we can ask you the question straightforward, or we can put in a little bit of a twist. So let's have a look at what we do for a bit of a twist with the midpoint formula. What they have done over here is they have told us that A is minus 5 and A. So the x coordinate is known, the y coordinate is not. Then over here at B, the x coordinate is not known. They give it to us as B. The y coordinate is 7. But they give us the coordinate of the midpoint, which is minus 1 and 3. So what I'm going to do now is I'm going to just still apply the midpoint formula normally, but this time I'm aware of the fact that I know my answer. So I'm going to say, how do I usually get the x value at the midpoint? I take the one x value, which now is B. I add the other x value, which now is minus 5. I divide it by 2, and the answer that I get will be the x value at my midpoint. But I know the x value at the midpoint is minus 1. So I've got an equation that says b minus 5 over 2 is minus 1. Now, in order to solve for b, what I'm going to do, I'm going to multiply through by 2. So b minus 5 is equal to minus 2, and solve this simple linear equation. B is minus 2 plus 5. So B is 3. Let's have a look at the sketch. Yeah, B could be 3. That looks about all right. No problem. Now I'm going to find A in exactly the same manner. I'm going to say the one y value plus the other y value divided by 2 gives me the y value at the midpoint, which is 3. Now, all I need to do is solve this equation. So A plus 7 is equal to 6. I'm multiplying through. So A is equal to 6 minus 7, which is negative 1. And again, that looks entirely consistent with my sketch. So I think we'll agree that the midpoint formula isn't the hardest thing that we've ever done. Right, guys, final question, question 9. It says, in the diagram, triangle ABC is drawn. Answer the question which follows. So they give us triangle ABC and they give us the coordinates at the vertices, so that's all very nice. And the first question asks us to calculate the coordinates of D, which is the midpoint of AB. That's fine. So I'm going to say, in order to calculate the midpoint, I need to take the one x value, add it to the other x value, so minus 5 rather, plus negative 7 over 2. That gives me minus 12 over 2, which is minus 6. And then for the y values, the same. I take minus 2, I add negative 8, and I divide by 2. That gives me minus 10 over 2, which is minus 5. And remember, keep it tidy. Write your coordinate nicely like that. So D is minus 6 and minus 5. Right, so that's the first question, straight application of the midpoint. Nothing too bad. Second question, predictably, asks us to calculate the coordinates of E, which is the midpoint of AC. So minus 6 and minus 5. Just putting D in. Right, so we're going to do exactly the same thing. Minus 5 plus negative 3 over 2. That's minus 8 over 2, which is minus 4. And again for the y's, negative 2 plus negative 6, which is minus 6, divided by 2. So I then see that E is minus 4, minus 4. Fine, another straight application of the midpoint, so that's not too bad. I think part of our question is missing, but I think what the question wanted to say is, without using a calculator, show that DE is parallel to BC. So, well, let's do that. I'm going to calculate the gradient. Let's start off with BC. Minus 8 minus 6 over minus 7 minus 3. So I'm going to get negative 2 at the top. The bottom I get negative 4. So the gradient of BC is 1 over 2. Now I think I can still remember the coordinates here. That was minus 6, minus 5, and minus 4, minus 4. Right, so let's calculate the gradient of DE. That is going to be minus 4 minus 5 and minus 4 minus 6. And what do you know? I get 1 over 2. You would obviously write that the gradient of BC is equal to the gradient of DE, so therefore the lines are parallel. So we've done that. Then the next question asks us, what type of quadrilateral is DBCE? DBCE. Now, this is where our properties of quadrilaterals become very important again. Boys and girls, we've shown that DE is parallel to BC. Now, it's pretty obvious from the sketch that those are the only two parallel sides. These sides definitely aren't parallel because, in fact, they meet over there at A. It also doesn't look like any other sides are equal in length. So a quadrilateral that has one pair of opposite sides parallel is called a trapezium. So I can say that ABCD is a trapezium. Right, boys and girls, I hope that you guys have learned a lot from this lesson. Remember, midpoint formula, distance formula, gradient, and you have to be able to apply all of these concepts in one big question. Read your questions carefully and make very sure that you have a mental picture of what your answer is meant to look like, because that often eliminates silly mistakes. So we hope you'll join us again for our next session, but for now, goodbye.